Hey guys. All right. So apparently we had a number of issues with the quiz. So all the odd students, I don't know what went wrong. I set them both up the exact same way, so I don't know why one was able to work and the other was not. Some of you suggested an April Fool's joke. I'm not that smart to come up with that as an April Fool's joke. So maybe Microsoft was playing an April Fool's joke on us. Um, but a number of you have had some questions. Just a couple of them. So I'll be grading. Obviously, I'll be still grading all the quizzes by hand, going back through and kind of tweaking some of the scoring on that because of can't do everything perfectly, and obviously the text-based questions I'll have to go back and apply points based on that. But just a few questions. One was some of you pointed out in the student object. So apparently one of the big questions, let me see if I can pull it up here. Pull it up. This question here. Yusuf, I don't know. The assignment was closed at a certain time. The due date was Tuesday at 1:30, and the assignment was closed today at 1:30. I stated in the syllabus that 2 days late would be anything more than 2 days late, anything more than 48 hours late would not be accepted. So. And the system does it automatically. I can't go back and change it. Okay, so here we go. All right, so some of you had a question about this one. All right, I created a student object and assigned it to the variable my student. Which of the following are possible outputs when I run the following line of code? System.out.println my student. So the question I wanted to see if you guys understood. Okay, do you understand that what this does is it takes the toString method of the student class and give me that and then displays it. Okay, so some of you pointed out, hey, you know what? I could have put the name Assistant Professor Joseph Leday as the name of the student, and you're right. I had not considered that. I had not thought about that. So therefore, yeah, you're right. That could have been their name. So if you had selected this one, not this one, this one would have been okay. Not this one. We will, and I'll explain why in just a moment. So if you did that, yeah, I could see your reasoning for that. I can go for that. All right. The reason why this one is not possible is that's an invalid email address. There's no way I should not have been able to create a student object with this email address. Okay. It should have either given a default value. If you were a default value, the odd number student number was the default value. Then you should have given. You could have made it null. You could have. You could have given your own email address as a default value, or any other valid email address as a default value. Okay, so but this is not a valid email address, so it doesn't make sense that this would be our default value. Okay, some of you pointed out, well, we don't know how you created the student object. Maybe you created it with bad parameters. Well, the thing is that if I didn't put any parameters, like if I tried to do student with no parameters in it, then that would be what type of error? What type of error would I have gotten? Anyone? Let's see. Let's say that the line, I'll type it in here real quick. Let's say that the line for creating the student object was student, my student equals new student 1, 2, 3, 4. Okay. All right. That's not right. All right, that's not the right parameter list for the constructor for student. So what would happen if I tried to run this code? Compiler error. Yes, correct, Rajab. Can I run this line of code if I have a compiler error? Nope, that's right, Ilkin. I cannot run this line of code, but here I'm saying is what happens when I run the following line of code? So the assumption is that the student object must have been created successfully. Okay, this would be like if I were to tell you, I drove to Ankara. I went to a place that you may have heard of called, what is it, Aksaray? Beyazsaray? I can't remember what the name of that. There's a big house there. There's a big house there in Ankara. All right, and I go, and I knock on the door of the sarai up there. And who am I expecting to see? All right. What would be a correct answer to that question? Who would I expect to see at the big? What's the name of that place? The Beyazsaray, Aksaray. I can't remember that. I can't remember what it's called. It's. I don't know. I can't remember what it is in Turkish. Yeah, I would expect to see you, Rajab. Right. Exactly. Right. So would you expect a correct answer could be, well, I don't know, Hoja. You might have gotten into a car accident on the way. Would that be do you think that would be a correct answer? All right. So I understand that. What's that? Okay. So I understand why you might have thought, oh, we don't know if it was, but the fact that we are able to run this line of code, the fact the question is asking you to run this line of code suggests that the student object was created successfully. Okay, I think one of the things that you guys need to understand, and that I've been trying to tell you since last year, and I'm trying to tell you again this year, I am not here to trick you. Okay, I am not here to try to throw some tricky stuff at you and try to see if you can, oh, do we understand the trick? Do we understand the trick question? I'm not here to do that. Right? I'm going to be as straightforward as possible with you. I just want to know, do you understand what happens when we write computer code and when we write certain types of code? And so in this example, what I was trying to see was, do you understand the basic format? Right. Well, the student object and this are going to be part of the same line. Yeah, so after the student object was created and when I run this following line of code, the idea is that if there were an error of any kind, whether it be a compiler error like this, or whether it be, what was the student? It was what? Student stuff was name. So if I created it using name, email. By the way, this, according to the way that I solved this would have been a valid email address. Okay, that would have given me no error. Number, department, and I could just say, okay. So if I run it like this, all right, so if I create this and then I print my student out, yeah, okay. So whatever name was, so Joseph Leday, Assistant Professor Joseph Leday, Professor Joseph, whatever. All this information. If we did something wrong in here that could have generated a runtime error, then this line doesn't get executed, does it? If we did like before, where we did the wrong format. Like this would be a wrong format. This would be a wrong parameter list because of the string there. Then this would be a compiler error. And again, we would not run this line of code. The question I'm basically asking is, do you understand what are potential valid outputs for the toString method of the myStudent of the student class, right? And and that's why those of you who called my attention to say, hey, these two right here, I could have taken this guy's name, Assistant Professor Joseph Leday. I could have made that a name. And that's why I said, yeah, you're right. You could have. And that shows me that you understand how this could have been done, right? You understand how you could have gotten to this output. All right. Right, but Muhammad, what I'm saying is that if that runtime error happened here, this line of code doesn't get run, does it? Right, but the question says, what happens when I run this following line of code? But if I can't run this line of code, then I can't really answer that, can I? There's no way that this line of code could produce an error. If we received an error previously, like here, that's a compiler error. This is a compiler error. Therefore, these two lines of code don't get run at all. This could generate a runtime error. But if this line generates a runtime error, this line of code doesn't get run at all. So if there had been an option here, right, that the point is you were looking for it. I think you guys were looking for a trick that wasn't there. I'm not trying to trick you. I'm trying to say this line of code gets run. What happens when this line of code gets run? Maybe your previous teachers, maybe your high school teachers and stuff liked to try to trick you. Maybe other exams that you've taken have tried to trick you. I'm not trying to trick you. I just want to know, do you understand the possible outputs of the toString method for the student class? That's really all I'm trying to test in this. Okay. I wasn't trying to trick you. And anyway, but I think that maybe you were looking for a trick and it wasn't there. And maybe there is some English communication, but again, if I say when I run the following code, what happens? How could this, if you can explain to me, okay, I'll give you this, I'll give you the points. If you can explain to me how this particular line of code could result in an error. Okay, so if anyone wants to message me privately, not on the chat, message me privately for how that line of code could produce an error, then I will give you the points for this question, if that was your answer. Okay, because I don't see how it could, but I don't know everything. And so maybe if you know some way that line of code, because the only thing this line of code does is it goes to the toString method of the object that myStudent points to. It goes to that method, gets that string, and it displays it. That's the only thing that line of code should be doing. Yeah, I'll think about the whole get title thing. I think that's my bad. That's on me because I didn't clarify which get title method I was looking for. I guess I kind of had hoped that you guys would understand that it was looking for the one that wasn't just a straightforward getter. But you know what? That's my fault for not making that clear. So if you put the get title method for your course class, well, that's a hard thing in a course class. Anyway, if you put the get title method for your course class, then I cannot ethically, in my opinion, take points away for that. So if you put the get title method for your course class there, which pretty much is simple, just return title, hopefully, then I'll give you points for that. That's fine. Well, Ilkin, I can't. Is it Ilkin or Ilkin? I can't. I'm not sure. I mean, I've said multiple times that this here, I've talked in our classes multiple times that this part here creates the object. This part here creates a memory reference to an object of a certain type. And then this equal sign assigns this object to the variable that this is creating. I think I've gone over that multiple times in this lecture series. So I had hoped that it would be kind of clear that, yet again, this part here creates the object. I've shown this using the whiteboard. I've shown this in the lectures in class. I didn't know any other way to word it other than how I had done it in class so many times. So this part here creates an object, assuming that everything is, assuming that there was all the parameters are correct for the constructor. This part then creates an object out there in memory somewhere. This creates a variable that can point to an object of a certain type. But why would that happen? Because if the email is invalid, then if you get a runtime error, then that should happen during the constructor phase, not during the print line part, right? Based on the instructions, if an invalid email was passed, then you should have either given a default value if you were in one set of students, but if you were in the other set of students, you should have gotten a runtime error as part of the constructor. Okay. All right. Well, unfortunately, we don't have any more time to be able to go over this particular stuff anymore. We have a lot of information we need to go ahead and introduce. A lot related to all this stuff that we're talking about here with the exceptions and the runtime errors, because it is exception handling time. So one of the nice things, there we go. One of the nice things about object-oriented programming is we can do exceptions so that if an error is encountered, we don't have to we can in the program, or we can handle it, but we can basically either throw exceptions. We can cause an error, cause a runtime error if an error condition happens or something we're not prepared to handle happens, or we can catch them when they do happen so that the program doesn't have to end. You know what? First thing, I forgot I put this in here. So attributed to Thomas Edison, inventor of the light bulb, or at least, well, that's a debate, isn't it? But one of the quotes attributed to him is, I have not failed. I've just found 10,000 ways that won't work. So Edison was before his time on some things. So the idea being that just because something doesn't work now doesn't mean that it won't. Doesn't mean that our plan is destined to fail. So we don't just give up, right? If I want to get to Ankara and I want to go see my friend Recep, right? If I have problems along the way, if I have a flat tire, let's say, for example, the president invited me to come see him, to come, have tea with him, all right? Well, I'm not going to turn that down. I'm not going to say no to such a prestigious invitation, right? Well, if I'm driving along the way and I get a flat tire, do I just say, well, I guess I can't go see him? Oh, well, no, right? I'm gonna go find another tire. I'm gonna stop at a gas station along the way, right? I'm gonna find something that works to get me there. Okay. So the idea is that so far, anytime that a program had some type of runtime error, the program would just terminate, would just end, right? A divide by zero error, an index out of bounds error, right? But sometimes we might want the program to continue and allow it to end gracefully, meaning allow it to end on its own terms. So for example, let's say that I'm at the ATM, I'm at my bank, put my card in, and I have 100 lira in the bank, and it asks me how much do I want to take out, and I say I want to take 200 out, and the bank has an error, right? It says, no, you can't take that, you don't have that much money. Do I want the program to just end and for it to keep my card and for the program to go back to the main menu screen and keep my card and not give it back? Well, of course not. What I'd like is for it to continue, for it to tell me, oh, hey, that's not an amount that you can take out. And if it goes back to the main menu, then it at least returns my card, right? So that's what we're going to introduce this section, right? And so here are some examples. I'll show another example. So what we'll do is, what time is it now? 2:15. Okay. So what we will do is we will have a break a little bit late. We'll go slightly more than an hour total on this first round. So about 3:05, we will take a break. I have something else I have to do for about 20 minutes, so we'll take a 20-minute break today. All right, but for now, and so what we'll do is after that long break in the second part, we'll talk about examples. I'll pull up my IDE, my JGrasp IDE, and we'll talk about some examples. Okay, and these are some really good ones just to show basics of exceptions. Okay, different types. Okay. Now, we've talked in this class about UML. So this is basically a UML diagram. Right? Now remember, every class that we every class that we create, every class that we create is some type of child of object. All right. So remember, if a class has no parent, if we don't say extends to it at all, so in the case of the assignment 1 that you guys just finished, person was a class that did not have a parent. We didn't say person extends anything, right? Now, teacher extends parent, teacher extends person, student extends person, and grad student extends student, right? But what does person extend? What does course extend? None of those things, right? They don't extend anything. So but what we don't see is that they extend object, right? So they gain all of the methods, all of the public methods of object, right? But what we can see here is that there's all this other stuff, that there's also children of object. Right? The main ones now, there's some different types of errors. So, so these are some thrown by the Java virtual machine. Okay, representing the error class. Okay, there's not really much we can do with these, so we won't spend a whole lot of time on these, because if one of these kinds of things happen, there's really not a lot that we can do to catch it and do and move on. All right, so we'll skip over those. But this is really what this section, and then the following, this much more refined section, are the ones that we'll spend a lot of time on. All right, today. So exceptions are errors that are caused by our program, right? And they can be caught, or they can be thrown, or they can be passed up, right? So specifically, the ones that we're most concerned with, the ones that we're most familiar with, are going to be these runtime exceptions. So these are the types of things that I would have expected you to create if you were part of the even numbered students, right? Even the students who have even student ID numbers, right? I would have expected you to generate one of these. Now, since we have not yet been to these sets of slides before that assignment was due, you wouldn't have known that these were called this way, and you wouldn't have known that you could simply write throw new arithmetic exception, throw new null pointer exception. But there are ways you could have generated them using lines of code. Okay, some of these all of these really can be thrown just from writing a bad line of code, a runtime error line of code. Okay. But the interesting thing of what we're going to talk about now are what we can do if these do happen, right? We can catch them. We don't have to just let the program end unexpectedly. We can catch them. Okay. Right? Now, runtime exception and the error sections, right, are what's called unchecked exceptions, which means if you write a line of code, that has one of those exceptions or a potential exception in there, such as a divide by zero, such as an array index out of bounds, it means that the compiler won't do anything, even though, so it won't say, oh, it looks like you might have a divide by zero, because it doesn't know. It won't know that there's a potential divide by zero. Right? So it won't do anything. Okay. Checked exceptions, on the other hand, IO exception, for example, is an example of a checked exception. Okay. This is the type of thing. The checked exception means that when the compiler knows that there's a potential for an exception to occur, then you have to let the compiler know that you are going to take care of it if it happens. Okay. An example of that is the IO exception. At the end of last semester, we talked about file handling. This set of slides also includes all the file handling slides as well. The reason why is because file handling is an example of a checked exception. So if you remember, if you go back to your CSE 101, the end of last semester, remember that when there was a file operation, when you used the file class to create a file object for reading or writing, you had to write throws IO exception or throws exception, right? You had to write that in there, right? Or you had to include the file handling stuff inside of a try-catch block, right? And the reason why you had to do that is because IO exceptions are a form of checked exception. It means the compiler said, oh, I see a line of code that says file in it. I see a line of code that has a potential exception, pretty common type of exception. You have to let me know that you're going to take care of it if it happens. You have to let me know that you have code that will take care of this, that will either catch it or pass it up to the calling method. Okay. All right. So in a lot of cases, unchecked exceptions just show that there's some programming errors, some logic errors. You know, if we try to access an object or an object's methods through a null reference, right? Through something that hasn't been given an assignment, right? Then when that, you know, that's an error in our part that we did not assign it properly. An index out of bounds exception would be if we did not appropriately use a correct array index. We didn't check to make sure that it was correct. All right. So these are all of our unchecked exceptions. All right. So all of these other ones that are still in white, these are what's called checked exceptions. The compiler is going to check to see, is there these type of exceptions possible? The stuff in blue is the unchecked. It means if one of these exists in a program, the compiler won't know about it. The compiler won't check for it, and if it does happen and we didn't handle it, then we could end up with weird behavior. Okay. All right. So there are a few different things that we can do with exceptions. We can declare them. Now remember, if we look back at here, right? So an exception, such as an index out of bounds, argument, these are all children of runtime exception, which itself is a child of exception, which is a child of throwable. So it's a throwable class, which is a child of object. What does that mean? What that means is that all of these exceptions, these checked ones as well as unchecked ones, right, they're all types of classes, which means we can create objects of their type. We can create an arithmetic exception object. We can create an illegal argument exception object, right? And there's special type of objects that we can throw. They're the child of the throwable class, which means we can throw them. Okay, so here, all right. So let's say that we have a method 1 and a method 2. All right. So we can say that method 2 could throw a certain type of exception, could throw exception. Okay. If an error occurs, throw new exception. So notice here the new keyword. So what are we doing? We're creating an object of the type exception. And when we create that object, right, the new exception object, we throw it. We create it and we throw it. Okay. So there's a big difference between these two keywords, throw and throws. Okay. Throw exception actually does throw the exception. It actually does generate the exception and put it out there. Throws exception is an indication to the compiler this method could throw this exception. Throws does not mean generate the exception and put it out there. It's just indicating to the compiler this exception might occur in here. Okay. So throws is telling the compiler this method does something. Throw, when the runtime actually occurs, if this line is encountered, the exception gets generated and thrown. Okay. So if we throw the exception, what happens? Well, if I were to throw a ball at you, what could you do with the ball? normally do with a ball if somebody throws it at you? Yes, Dokkan, you catch it, right? So if you catch the ball, is the ball still flying in the air? Is the ball still out there? Is the ball still thrown? No, you have the ball, right? You caught it. The ball is yours, right? So if you catch the ball, if a method catches it, it says, I want to take this exception. I want to process it. Okay. So then what if this catch wasn't there? What if I threw the ball at you and you ducked? Okay. So here, I'm gonna turn my camera on. Maybe you can see me. Okay. I don't have a ball. I normally for this lecture, if we were in the class, I would bring a ball to class. I would actually bring one of my children's balls to class and I would throw it at you. All right, throw it at somebody in the class. But unfortunately, we're not here. So we're not all together. So let's see. I have this. Okay, there. I have my mask. Okay, so my mask that I can wear. All right. So let's say my friend over there is going to throw the mask. Okay, pretend it's a ball. Pretend it's a ball. All right. He's going to throw it at me. Okay. Let's see if I can do this. Let's see if it shows up on the camera. And when it comes, I'm not going to catch it. Okay, I don't know if you saw it, but it flew over there and now it's on the floor. All right. So I don't know if you quite understood, but if I don't catch the ball, if I don't catch it, then it's going to go past me. Okay. And I'm not going to do anything, and it's just going to get passed up to the person behind me. Right. Now they could catch it. Right. They could catch it, or they could duck. And they could say, I'm not going to catch it either. And we could keep going, right? So if you think of this line of people, gosh, I really wish this online class learning is just, I can't do any of my good examples, right? Okay. So you have person, person, person. Now let's think instead of person, person, person in line and the ball is coming at them. Let's think instead it's method calls a method calls a method. Okay. And an exception happens. So an exception gets thrown to my method. Right? If that method catches it and processes it, this method and this other one, they don't do anything. All right. They just keep on processing. They're like, oh, I called him. He's going to do some stuff. When he returns back to me, then I'm going to continue my processing. Okay. If the first method does not catch the exception, they just don't do anything. They duck. Think of it as they ducked, they're out of the game. They didn't catch the ball, they're out. Okay? And the ball's going to come, the exception is going to come to the next person. And if that person catches it, they can process it. All right? They could process it, or they could not, right? They could say, I'm not going to catch it. If they don't catch it, they duck. They are out of the game. They're gone. The exception keeps going along. It's flying. They threw it hard, right? They threw it really hard and fast. Last person, do they catch it? Maybe, maybe not. If they catch it, they process it. Exception goes away, ball goes away. If they don't, if they decide not to catch it, they duck. If they are the last line of defense, the last method that was called, what happens? Right. In our case, in the case of a real game, I don't know what would happen if you tried to throw a ball at 3 people in a row and they all ducked out of the way. I don't know enough. I don't know enough about football, or I don't know enough about. I've watched a few matches. I watched a few Ontario sport matches and some other teams, but I'm American, so I don't know much about how football works. But in programming, if no one catches that exception, that's what you've encountered so far with errors. That is what you have seen so far, that the error gets generated and pushed all the way up until no one catches it. It ends the program, and you see this big, ugly error on your screen. Okay? So that's how the whole idea of throwing and catching and passing up, because if I don't catch it, then it moves up to the method that called me. Okay. All right. So you guys have seen my face long enough. All right. But these are some keywords that you need to know. Throw generates and, well, new exception creates the exception object. Throw actually puts the exception out there, and the exception stays until it gets caught or until the program ends. One of those two things is going to happen. Okay. Throws is simply an indication to the compiler that, hey, I know this exception could happen, right? So don't give me a compiler error. Don't you give me a compiler error. I know that the exception could come around. Okay. For checked exceptions, we need to have this, like IO exception and just the exception class. If it's a runtime exception, like a divide by 0 or something like that, we don't have to tell the compiler that we know about it. Okay. Try. Try is when there's a block of code where an exception might happen. Okay. Doesn't mean it will happen, just means that we know that it might happen. We try something. If an exception occurs inside of this line or inside of these lines, we catch it here and we process it. Okay, so the 4 new keywords that we've introduced here that you need to know: try, catch. Okay, oftentimes we'll refer to this as a try-catch block. Okay, try, catch, throws, and throw. Okay, so you need to make sure you know those 4 keywords. And then there's going to be a 5th one coming in just a little while. Okay. Now again, the throws keyword just tells me we know that there might be a checked exception that could occur in this block of code. All right. So throw the new keyword, like I said, creates the exception object. Throw actually puts it out there. We could also do it this way, where we can take an exception object, assign it to a variable, and then throw the variable. Either way. Okay. These two would be basically doing the same thing. So let's say we know we want to create an exception if an argument is invalid, right? If we have an invalid argument. Okay. So we're telling the compiler, we know that this method could potentially throw an illegal argument exception. Then we're going to throw new illegal argument exception if the radius is negative. So notice here that we didn't set a default value. So technically, if those of you who did assignment 2 did it this way, illegal argument is not, is it a runtime? think it's a runtime error. Oh, actually, it is. Okay. So actually, we didn't have to tell the compiler about this. Right? We could have just done it this way. That's fine. Okay. So this could have been an example of a runtime error you could have done. But even this would have been beyond what I would have expected a lot of you to be able to do. And I'll show you some examples of what you could have done, okay, when we do the examples in the second hour. All right. Second. Yeah. All right. Here's some other things that we need to know about the catch. So just like if statements, think of this as an if else. If we catch the exception here, the exception is caught. There is no more exception. It's gone. Right? So if the exception is caught here, none of this can be done because we've already caught the exception. Right? Got it? If we catch it here, we don't catch it here or here. There are some conditions where we might, but basically, this is a way that if a certain set of statements could possibly give us multiple types of exceptions. So let's say we have some lines of code. There might be a divide by zero error. There might be an index out of bounds error. There might be an illegal argument error. All right, these are all possible things that might occur. All right. And we want to handle things differently for each type of error. Okay. So we catch something here. All right. If we catch it here, we can't possibly catch it here. All right. All right. So let's look at an example here where you got a few different methods we're doing stuff with. Okay. So you have a main method that calls method 1. All right. Method 1 here. We invoke method 2, call method 2. Right. Call method 3, and let's say that an exception is thrown inside of method 3. Now, depending on the type of exception means things may go differently for us. Let's say that all 3 of these, exception 1, 2, and 3, are all different types of exceptions. Okay. If the exception thrown, okay, first of all, no matter what, in this example, statement 5 is not happening. Okay. Statement 5 will not execute because an exception happened in method 3. Okay. So let's say that the exception that's thrown is this exception 3 type. We process it. Exception's done. It's gone. We execute statement 6. We go back here. We execute statement 3 and 4. We go back here. We execute statement 1 and 2. Okay. Let's say that the exception thrown is not of exception 3 type, but it's of exception 2's type. Okay. We skip over statement 5. We skip over statement 6. We come up here. So now it's almost like an exception was thrown in method 2 instead. We skip over statement 3. We process our exception 2. We execute statement 4, 1, and 2. Now finally, what if the exception thrown is not of type 3 or 2, but it's of type 1? We skip over statement 5. It's not this type of exception. We skip over statement 6 because we passed up to here. We skip over statement 3, skip over statement 4. So it's like an exception was thrown in method 1. We skip over statement 1. We process our exception 1, and we execute statement 2. I'm over here doing the mouse over here on this screen instead of this one. Okay. All right. And then finally, one final example. What if it's none of these three types? What if the exception thrown is none of these three types? Well, exception happens here. We skip over statement 5. It's not this type, so we go back up here. Exception was thrown in method 2. We skip over that. It's not this, so we skip over that. We come back over here. Exception was thrown or passed along in method 1. We skip over statement 1. It's not of this type. We skip over statement 2. We exit the program with an exception that has not been handled. Okay. We'll look at some examples of that. Okay. All right. So suppose P2, that we have a method called P2 that throws an IO exception, and we check that if a file doesn't exist, we throw this new IO exception. This will automatically is done this if we throws IO exception. If you use the file class and the scanner on that file class for a file that does not exist, all right, this does this automatically. There's the IO exception. Okay. All right. So you must be able to handle that, because if P2, so it knows that P2 throws a certain type of exception, which means that you must either put inside of a try-catch block that call to the P2 method to handle the IO exception itself, or you must indicate that P1 also throws the IO exception. The reason why this is that if you want to handle the IO exception inside of P1, that's fine. You can do that. That way, if an exception occurs in P2, we handle it here and move on. But if we don't handle it here, it means that if an exception gets thrown in P2, it's going to be passed along through P1. Remember, this is like P1 being that guy that the ball is thrown at him and he ducks. All right, he ducks and the ball keeps going. Right. In this case, P1 says, "I don't want this. You take it." All right. So if an exception occurs in P2, what will happen is P1 will also throw an IO exception. All right. Okay. One final thing before we get to the fifth that I talked about, the fifth new keyword of the day, is we can rethrow exceptions. And what that means is, let's say that there's some statements. We want to catch an exception if it occurs. We want to do some type of operation. Maybe it's display something to the user. Maybe it's log an error in a text file, in a log file. But we don't want the program to just continue on. We want to do some stuff with the exception, but we still need the program to end. All right, we can, what we say is rethrow the exception. So here we can throw the same exception again. Remember, this catch, it's kind of like a method call, right? Where we're saying whatever the exception type is, this is a variable. We're putting the exception object into this variable. We're assigning it to that variable. So the entire catch block, any reference to this variable, will be referencing the exception object. Okay. So then if we throw the exception object again, we just send it back out there. This would be like they throw a ball to you, you write your name on it, and you throw it to the next person. All right. They throw a ball to you, you do something with it, and you throw it to the next person. Okay. And our fifth new keyword, finally. Okay. Now, finally is a keyword that if there are certain statements that we want to execute, even if an exception occurs. Okay. We want certain statements. It doesn't matter. Exception, no exception. We want these statements to happen. All right. So if we try, some statements happen, no exception occurs, we go to the finally, we execute those statements, and we're done. If an exception does occur, we try something, an exception occurs, we go to this section, we handle it. After we're done handling it, we do this. Okay. An exception occurs even that's not of this type. An exception occurs that's not the same. That's not this type. Okay. Then we do this. We skip over this because it's not of this type. We still execute the finally statements, even though there's an exception out there, and we move on. And we go back up to the calling method. Okay. So let's see it traced. So let's suppose, again, this is what I said a second ago, no statements, so no exceptions occur in these statements. We just do the finally, we move on, and we're happy. Okay. So now let's say that an exception of type exception 1 is thrown. So exception one is what we catch over here. All right. So if we look back here, let me go back a moment. We executed statement 1. We had an exception in statement 2. We don't execute statement 3 because an exception occurred. So we move on, we catch the exception. We still do the finally block. We still do the next statement because, right? We still do the next statement because now the exception has been handled. There is no exception out there that's stopping our execution. And we'll keep going. So now let's say in statement 2, there's an exception of type exception 2. We don't execute statement 3. We skip over it. We don't do this section, right? Because exception 2 is the type of the exception that happened. So we don't execute this section. We do this. We handle the exception, but you're saying, wait a second, wait. Why are we doing finally? We handled the exception, but we threw another exception. We threw the exception again. So now there's an exception still hanging out there. Because even if an exception is not caught, the finally is still going to happen. We're still going to do the finally no matter what. Okay. So we do the finally. We rethrow the exception. What about this? What about next statement? Does next statement get executed? Yeah, we skipped over statement 3 because there wasn't an exception occurred. If there is an open exception, if there's an exception that's still not handled yet, we won't execute any statements. Yeah, we won't execute any more statements except for possibly ones that are in a finally block if there is an exception that has not been handled. Yeah. All right. Right. Statement 3 was not executed because there was an open exception. There was an exception that had been thrown. It was caught here, handled here. You know, there was like some statements here, maybe like a log file written to, or a, displaying something to the user, something like that. Then it was rethrown. All right. The finally statements were executed, but the rethrowing of the exception meant there's an exception out there. I'm not going to execute anything else until this exception is handled. All right. Which means this next statement will not happen. It will not happen. It's going to throw the exception up to the method that called it and say, you need to handle this, or you need to keep passing it along until the program ends. Okay, this might be a good example for us to look at. Okay, and I'll show you why. All right, good example for us to look at. All right, just some cautions to think about when using error handling. All right. You know, we may have to propagate errors to different methods that call. There's some issues stuff, but it is very useful to be able to use exceptions. And in fact, your next assignment is going to be based on you creating your own exceptions, okay, and using them yourself. Okay. So ideally, what we would like is if an exception is to be processed by the method that it occurred in, right? We should we would like it to happen where it can handle the exception in the method where it occurs. So we don't need to throw it, we just catch it right there in the method. But if for whatever reason we say no, we don't want this method to process this exception, we can throw it, and the calling method will deal with it. An example like this would be if we accidentally did a divide by 0, we might not want the loop, the if statement, the loop, or whatever, where the divide by 0 occurred, right? We might want to be able to have some calling method deal with it. All right. Okay. Or in the example of, for those of you who are even numbered, your student number is even, that you were to generate an error. I didn't want you to handle that error. I didn't want you to catch it. I wanted us to catch it, the calling methods of our test cases to catch it, to make sure that it's there. Okay. All right. Okay. Right. So you should use exceptions. You should use exceptions to deal with potentially expected error conditions. Or sorry, unexpected error conditions. All right. For example, here we have a try-catch block where we want to print the toString method of a certain reference variable, right? And if the reference variable, if it happens to not point to anything, we haven't given it a value yet, we catch the null pointer exception and say ref var is null. Okay. If there's a strong possibility that sometimes this reference variable might be null, might be nothing, right? We don't really want to use a try catch block because this is going to create an exception object and it's going to do a bunch of stuff, right? So instead, what we could do is this. Right? Just check it with a simple if statement. If it's not null, print its toString method. Otherwise, print our reference variable is null. You could also do this using a ternary operator, right? The question mark with the colon. Right? Okay. Right. So this might be a little bit confusing to us as programmers. It might also require lots of extra object creation that we don't really want to do with. Whereas this, much more simple, much more clean, and does not require extra exception object creation. Okay. All right. Now, like I said, we can create our own exceptions. Right. We can extend exception or extend runtime exception. Right. Get used to the whole extending runtime exception. That's what assignment 2 is going to be all about. I mean, you creating your own custom exception classes. Right. For the most part, this assignment is not because we are somehow lacking exception classes. The ones in the API generally are okay. This is so that you can get familiarity and understanding of how to create your own exceptions, throw exceptions, and catch them and do stuff. Okay. All right. So we'll look at some examples of some exceptions where we create our custom exceptions. All right. All right. Now, I'm going to skip over the assertions stuff here, only because, let me see. Actually, okay, that actually will end our discussion here. I'm going to go ahead and we're going to stop here for now. We will pick up with assertions next week because assertions are useful. This is a good place to introduce test cases because assertions are used in test cases and the JUnit test cases. So what we will do is we will pick up here next week on the slides. Like I said, when we come back, so we're going to take a lengthier break than normal today. It'll be back around 3:20, 3:25, something like that. All right, is where we'll start up again. And what we will do is we'll pick up there and we'll do examples. Okay, custom exceptions, and we'll talk about how to deal with runtime errors. All right, and we'll talk about try catch, and we'll use some examples about that. All right. Any comments or questions before we break? All right. Be here during the break, and I'll see you guys in about 20 minutes.